Welcome to This Day in His Story, created by American Heritage Worldwide, a reminder that every day holds something new to learn. Did you know that the first Indianapolis 500 race was held on May 30th in 1911 on a track that was built by an automobile dealer to test new cars? Learn that the first Indy 500 race featured 40 cars at the starting line. Learn why the Indianapolis 500 is often called the most prestigious automobile race in the world, and discover that the Speedway's original 2.5-mile track design is still used today.
Imagine risking your entire life, fighting through just terrible mud, suffocating exhaust, and the constant threat of your car breaking down, all just to hit a top speed of 74 miles an hour.
Right, which sounds so slow to us now.
Oh, totally. I mean, if you do 74 miles an hour in the left lane of the interstate today, you're definitely going to get aggressively honked at.
Yeah, you really are. It's just casual cruising speed.
Exactly. But back in 1911, achieving that speed required an absolute technological revelation. So, welcome to today's deep dive. We are looking at a stack of sources today chronicling the Indianapolis 500. A century of speed and wisdom.
Yeah, it's such a great topic.
It really is. We're tracing the evolution of, a muddy Midwestern testing ground into the ultimate cathedral of speed. But the core of this deep dive isn't just about, combustion engines and aerodynamics.
Right, there's a much deeper human element to this for you to think about.
Exactly. It's about a fascinating tension. Mankind's absolute obsession with pushing machinery to the breaking point, contrasted against the absolute fundamental necessity of pacing ourselves in our own lives.
Yeah, it's a contrast that really forces us to look at how we measure progress, honestly. Because we've spent over a century engineering ways to conquer wind resistance and friction, right?
Squeezing every ounce of horsepower out of metal.
Exactly. But we often forget that the human operating system just doesn't scale the same way a machine does. We can't just be upgraded.
Okay, let's unpack this first source document and really look at the machine side first. Because to understand the sheer scale of the Indy 500 today, we have to look at this massive engineering bottleneck that existed back in 1906.
And it was a very literal bottleneck.
Yeah, very literal. Because if you're an early car manufacturer in Indiana and you want to see what your new engine can actually do, you hit a roadblock, the public roadways.
I mean, calling them roadways it's a very generous term for what existed in 1906.
Just dirt paths, basically.
Yeah, you shouldn't picture smooth asphalt or, even leveled gravel. You need to picture rutted dirt paths that were originally carved out by horse-drawn wagons.
Oh, wow. So just completely uneven terrain.
Exactly. And when it rained, they became these treacherous, undrivable bogs. And then when they dried, those deep ruts essentially turned to solid stone.
So trying to go fast on that would just destroy a car.
Completely. If you tried to test a fragile early 20th century automobile at high speeds on those paths, the vibration alone would, shatter your wooden wheel spokes or snap an axle long before you ever reached top gear.
Right. So the environment was just completely incompatible with the technology they were trying to develop. So an Indiana automobile dealer named Carl Fisher decides to solve this.
And his solution was pretty ambitious.
Very ambitious. He goes and purchases 328 acres of farmland about 5 miles northwest of downtown Indianapolis, and he designs this massive 2.5-mile closed track.
And the basic design of that track is actually still there today.
That is wild to think about. But what's interesting is the intent wasn't really to build a sports stadium, right? It was basically a controlled laboratory. Manufacturers needed this baseline environment to test top speeds.
Yeah, they needed to pit different models against each other without the chaotic variables of public roads.
It's essentially like they build a giant private sandbox or, a beta testing server for car manufacturers.
Yeah.
Because the real world was just too buggy and broken to use.
That is a great way to put it. And what's fascinating here is that Carl Fisher recognized that the general public was actually highly skeptical of the automobile at this time.
Really? They didn't just instantly love cars.
Not at all. People viewed cars as these loud, unreliable, dangerous toys for the wealthy. Fisher knew that to sell cars to the masses, manufacturers had to prove durability.
So it was a giant PR stunt disguised as a test track.
In a way, yeah. The Indianapolis Motor Speedway was designed to be the ultimate proving ground. The logic was simple. If an engine and a chassis could survive a sustained test on Fisher's track, it could certainly handle your daily commute into town.
That makes a lot of sense.
Yeah.
But Fisher was also a businessman. right? He realized he could offset the massive cost of building this facility by turning that testing process into a public spectacle.
Right, he had to pay for this massive track somehow.
Exactly. So he started inviting spectators to come watch these manufacturers showcase their engines. It became this high-speed, live-action showroom.
But the initial strategy, it actually had some pretty major flaws. Fisher and his partners tried hosting multiple smaller racing events throughout the year.
Then people just didn't show up.
Not enough of them, no. The public interest just wasn't sustaining such a massive facility. They realized they needed a spectacle large enough to command national attention. They had to force the world's best engineers into a single high-stakes competition.
Which triggers a massive strategic pivot in 1911. They just scrap all the small events entirely.
Yep.
Completely shifted focus.
And they decide to host one single grueling endurance event every year, a 500-mile race. And to guarantee that every major automotive mind on the planet actually showed up, they offered the richest cash reward in racing history.
Which brings us to May 30th, 1911.
Yeah.
The very first Indy 500.
Right. 40 cars lining up, and honestly, I am trying to visualize what a 40-car race looked like before we had, digital transponders and automated timing systems. How do you even keep track of who is winning?
With extreme difficulty, to be honest. The scoring system relied entirely on humans, just guys with stopwatches, ledgers, and these clunky mechanical adding machines sitting up in a timing stand.
That sounds like a logistical nightmare.
It was. You have 40 cars covered in soot and oil passing the start-finish line every few minutes at over 70 miles an hour.
Oh, man.
Yeah, so spotters had to visually identify the painted number on the side of a blur of metal, shout it out, and then have a clerk tally the lap in real time. It required an absolutely unbroken chain of visual confirmation, which means it was incredibly fragile. And as the sources show, just 13 laps into this very first race, that fragility is completely exposed.
Right, because of the crash.
Exactly. There's a massive multi-car accident right on the front stretch. And the spotters and timing officials are, understandably, distracted by the chaos and the sheer danger of it all. They look away from the track to deal with the wreckage.
And that momentary distraction permanently broke the chain of data. The officials just lost track of the running order.
Wow. So they literally didn't know who was in what place.
Exactly. The finish of that first race was marred by intense controversy. There was this driver named Ralph Mulford who fiercely argued that he was the rightful winner.
Because he thought they missed one of his laps.
Yep. He claimed the officials had completely missed a lap of his while they were all focused on the accident.
But the officials ended up ruling against him. They declared Ray Harroun the winner. He took home this massive $14,250 prize, driving a car called the Marmon Wasp, which was actually built locally right there in Indianapolis.
And his time was pretty impressive for the era.
Right. Harroun completed the 500 miles in 6 hours and 42 minutes, averaging that 74.59 miles per hour we talked about earlier. But wait, this brings up a really crucial detail from our sources. Harroun's car, the Marmon Wasp, was the first car ever fitted with a rearview mirror.
Yeah, it's a huge milestone.
Which is wild to think about. If there were no mirrors before 1911, how did these drivers survive? Were they just driving totally blind to whoever was behind them at 70 miles an hour?
Well, up until that exact race, drivers utilized a biological solution.
A biological solution?
Yeah, they had a ride-along mechanic sitting in the passenger seat with them.
Oh, you're kidding? During the race?
During the race, the mechanic's primary job was to constantly look over his shoulder, monitor the traffic, and physically yell over the deafening roar of the open exhaust to warn the driver if someone was trying to pass them.
So you literally just have a second human being sitting fully upright in an open cockpit. Beyond just the sheer danger of that, the engineering penalty has to be massive. You're carrying an extra, 150 to 180 pounds of dead weight?
The weight penalty is definitely significant, but the aerodynamic penalty is actually so much worse.
Really? Worse than the weight?
Oh, absolutely. Think about the physics of a human torso sitting fully upright in a fast-moving vehicle. That mechanic is essentially acting as a massive asymmetrical parachute.
Oh, wow. I didn't even think about that.
Yeah, he is violently disrupting the airflow, creating this low-pressure drag zone behind him that actively pulls the car backward. It forces the engine to burn way more fuel and work so much harder just to overcome the resistance of a human body.
So by just mounting a simple piece of glass above his dashboard, Harroun eliminates the need for the mechanic entirely.
Exactly. He sheds the weight.
He sheds the dead weight, but more importantly, he smooths out the airflow over the whole cockpit. He basically solved a highly complex aerodynamic drag problem with a bathroom mirror. I mean, it's a literal instance of looking back so you can move forward faster. It's brilliant.
It really was a paradigm shift. But, it also set off this relentless technological arms race at the Speedway.
Because everyone else had to catch up.
Right, because the environment Fisher created was so intensely competitive, the engineering just evolved violently fast. Just to put it in perspective, a mere 10 years after Harroun won that first race, his cutting-edge speed of 74 miles per hour wouldn't have even kept him in the lead pack.
Just 10 years later.
Yeah, by the 1920s, his winning speed would have only put him in 10th place.
That is insane. I want to look closely at the mechanics of that 10-year leap, because a car from 1911 and a top-tier racing car from 1922 barely look like they belong to the same species. In the 1910s, cars were essentially these massive, heavy metal boxes. The prevailing engineering theory seemed to be, to go faster, you simply needed a bigger, heavier engine.
It was a total brute force approach to physics, just push harder.
Right.
But engineers quickly realized that pushing a heavy, flat-faced box through the air at high speeds requires an exponential increase in power. Air resistance squares with speed. So by the early 1920s, that design philosophy completely inverted.
They stopped fighting the wind.
Exactly. They stopped trying to overpower it and started trying to slip through it. The cars became significantly smaller and lighter. They introduced these narrow, streamlined grills at the front to cut the air and elongated teardrop-shaped tails at the rear.
Wait, why the teardrop shape specifically? Is that just an aesthetic choice?
Not at all. It comes down to fluid dynamics. If we connect this to the bigger picture of aerodynamics, when a flat-backed object punches a hole in the air violently swirls back together behind it.
Okay, creating turbulence.
Yes, and it creates a powerful vacuum that literally sucks the car backward. The teardrop shape, however, guides the air gently back together, which completely neutralizes that vacuum. It's the same reason a falling drop of water naturally takes that shape. It is simply the path of least aerodynamic resistance.
That is fascinating. And the mechanical architecture under the hood evolved just as drastically during this time. The sources show that by the mid-1920s, top cars were running 3-liter V8 engine.
Yep, the legendary V8.
We hear V8 engine constantly in modern car commercials, but what makes arranging 8-piston cylinders in a V shape such a massive advantage over the older engines they were using?
It solves several major engineering problems all at once. Before the V8 became dominant, many high-power engines used 8 cylinders arranged in a single straight line, an inline 8.
Okay, so just 8 pistons in a row.
Right, but an inline 8 is incredibly long, and the crankshaft running along the bottom of that engine is also very long. At extreme racing speeds, a long crankshaft basically acts like a wet noodle.
A wet noodle? That sounds terrible for an engine.
It is. It flexes, it vibrates, and eventually it just snaps under the sheer rotational force.
Ah, okay. So by taking those 8 cylinders and splitting them into 2 banks of 4, angled in a V shape, you effectively really did.
Yeah.
And that relentless trajectory of innovation brings us to the staggering reality of the Indianapolis Motor Speedway today. We started this deep dive talking about a muddy 328-acre farm with a few wooden grandstands. Today, the Speedway is the highest capacity sports venue on the planet.
Yeah, the scale is almost difficult to conceptualize unless you see it in person.
It is mind-blowing. The permanent seating capacity alone is 257,325. But when you factor in the infield seating, the venue holds 400,000 people.
That's just unbelievable.
That is an entire mid-sized city descending on 328 acres of farmland just to watch humans defy the laws of physics. Because the cars today aren't averaging 74 miles an hour. Speeds of 235 miles per hour are totally standard.
It's an entirely different universe of speed.
The fastest lap ever recorded there was set by Arie Luyendyk in 1996, clocking an unbelievable 237.498 miles per hour.
Just think about that. To travel at 237 miles an hour means you are covering roughly a full football field in a single second.
A football field a second. That is terrifying.
The violence of that speed, the sheer G-forces exerted on the chassis in those corners, it's something the engineers of 1911 couldn't have even theorized.
And this reality, this incredible century of engineering that culminates in 237 miles an hour, it really forces an absolutely critical realization for us. Because the entire history we just laid out is about upgrading machinery.
Right, swapping out parts.
Yeah, you swap out an inline engine for a V8, you swap out a flat rear end for a teardrop tail, you remove a human mechanic, and you bolt on a rear view mirror. When a machine reaches its limit, you just replace the parts to make it go faster. But you cannot do that with the human being sitting inside the cockpit.
No, you definitely can't. We are not modular. We are organic, closed systems. And this is exactly where the history of the Indianapolis 500 serves as a profound mirror for our own lives.
Oh, I love that.
Because we often view ourselves the way engineers view those cars, right? We think if we just optimize our schedule better, multitask harder, and ignore our own exhaustion, we can continuously increase our personal top speed. But the human operating system is just not designed for endless velocity.
Which brings us to the ultimate engineering manual for the human condition. The scriptures don't treat the limitations of the human body as a flaw to be engineered away. They treat them as a reality to be respected. In Mosiah chapter 4, verse 27, we are given a direct, factual mandate on how to operate our lives.
And it's such profound counsel.
It really is.
Read out.
It states, "And see that all these things are done in wisdom and order. For it is not requisite that a man should run faster than he has strength."
This is just a fundamental fact of life. It is the established law of human endurance. And notice the wording there, wisdom and order.
Yeah, that stands out.
A race car vibrating apart because the crankshaft is too long is a failure of order. But a human being burning out because they're trying to maintain 237 miles an hour in their daily obligations, that is a failure of wisdom. We have finite horsepower.
That is so true. And that principle is reinforced again in Doctrine and Covenants, chapter 12, verse 4. The counsel there is completely explicit. Do not run faster or labor more than you have strength and means provided to enable you to translate, but be diligent unto the end.
It's the exact same truth.
When I read that, the connection to our deep dive is just undeniable, because the strength and means provided is the fuel in your tank and the structural integrity of your mind and body.
Exactly. The contrast is vital for you to understand. We spend all this time building machines to run faster and faster, but this scriptural law requires us to temper our own pace. Because life is not a qualifying lap. It is an endurance event.
Right. You have to last the whole distance.
If you labor more than you have the strength to sustain, you do not reach the finish line faster. You blow the engine.
And the key phrase in that scripture is, be diligent unto the end. Diligence is not about blind speed. Diligence is about consistent, deliberate effort paced over time. Ray Harroun didn't win the first Indy 500 because he had the ability to go 200 miles an hour for 5 minutes.
No, his car would have fallen apart.
Exactly. He won because he maintained an average speed of 74 miles an hour for 6 hours and 42 minutes. He operated within the strength and means provided by his machine, and he outlasted the competitors who pushed their equipment past the breaking point.
It requires deep self-awareness to recognize when you are exceeding your own strength. It requires knowing exactly when you need to pull into the pit box, refuel, and just let the system cool down.
When we step back and look at the whole picture we've explored today, the journey is just incredible. We tracked Carl Fisher turning a muddy rut in Indiana into a high-speed laboratory. We unpacked the aerodynamic breakthrough of a single piece of glass acting as a rearview mirror.
And the birth of the V8.
Yes, breaking down the fluid dynamics and mechanical evolution of the V8 engine in the 1920s. And of course, marveling at 400,000 people gathering to watch humans cross a mile of asphalt in a matter of seconds.
It is truly a testament to human ingenuity. We have mastered the art of making the external world move faster.
We really have. But the internal world, the human soul and body, operates by the unyielding laws of wisdom and order. You have to ensure that in your own pursuit of progress, you aren't laboring beyond the strength and the means you have been given. Pace yourself, be diligent, but respect your biological and spiritual limits.
Master the discipline of endurance rather than falling for the illusion of endless speed.
Which leaves us with a final thought for you to mull over as you carry on into the rest of your day. We talk at length about how Ray Harroun invented the rear-view mirror to physically remove the ride-along mechanic from his car. It was a brilliant shortcut to eliminate drag and just go faster.
A literal technological shortcut.
Exactly. So in our own lives, as we try to survive the breakneck speed of the modern world, what rear-view mirrors are we inventing today? What shortcuts are we taking just to go a little bit faster? And more importantly, are we shedding the vital human connections and the warnings we actually need just to shave a few seconds off the clock? Think about it.
Thank
Have
you
a great
for joining
day,
us for
and
this
we'll catch
day
you
in
on
his
the
story.
next deep dive.
May the lessons of yesterday inspire you to see God's hand today and to play your part in his story now. For more faith-based learning, visit ahsworldwide.org, the homeschool for faith and family.